Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think yesterday we were discussing about the preparation of naphthol. Actually we are discussing the reaction of naphthalene. In our previous lecture we have discussed about the preparation of naphthol. There are different methods for the synthesis of naphthol, starting from, and as we know that there are the two isomeric forms are generally obtained for naphthalene. Naphthalene is nothing but as a two benzene ring fused together, means they can share two carbon atom sharing equally and at a fused junction, and that type of the compounds are known as naphthalene. And how to prepare that naphthol? Alpha naphthol as well as beta naphthol. So naphthols are prepared by fusion of sulfonic acid with alkali. Alkali generally we know that sodium hydroxide. So starting material here as taken as a sodium salt of sulfonic acid treated with 2 moles of sodium hydroxide at 300 degrees centigrade, that gives rise to the intermediate product form, that is nothing but as a sodium naphthoxide, and that sodium naphthoxide further acidified with dilute H2SO4, resulting compound obtained will be the aphtha naphthol, or we can call it as a 1-naphthol. This is the first method. Now second one, the sodium salt of sulfonic acid when treated with 2 moles of sodium hydroxide under 300 degrees centigrade, but here the position of that sodium sulfonic acid at 2 position means at a beta position, and therefore the resulting compound obtained will be the beta naphthol, or we can call it as a 2-naphthol. So these are the thing we have seen so far. Now let us look at the remaining reaction we will discuss about. So today we are going to discuss the remaining reaction of that naphthols. So alpha naphthol can be obtained by hydrolysis of corresponding amine. So let us see here, A and B we already discussed, that is a C, that alpha naphthol can be obtained by hydrolysis of corresponding amine. So alpha naphthol can be obtained by hydrolysis of corresponding amines, corresponding amine. As we know that the general formula of amine is a RNH2, where R may be as a alkyl group or the aryl group, where NH2 is a functional group of the amines. And as we know that all amines are basic in nature, generally those organic compounds containing nitrogen atom are basic in nature. Why they are basic in nature? Because they containing as a nitrogen atom, and nitrogen atom has a lone pair, and that lone pair are readily available for donation. And according to the Lewis-Base theory, according to us that Lewis-Base theory, we can call it, it is a electron donating species are the bases. So according to that, we see here, let us see alpha naphthol, that is the end product we are going to get, corresponding amine. Let us see the starting material, the corresponding amine which I am going to take over here is this one. Let us see, this is the compound which is a alpha and this side is a beta. So we are going to prepare the alpha naphthol. So we must take the amino group at one position. As we know that the naming system 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 likewise. So at one position it is termed as alpha naphthol. This is a alpha naphthol which is our starting compound, or we can call it as a 1-naphthol. 1-naphthol. So that is our starting material. When this is treated with the dilute H2SO4, at 200 degrees centigrade, what it gives, and the pressure, that is a 14 atmosphere pressure. This is applied over there. After keeping this reaction condition, the resulting compound obtained will be this one. Let us see, this is a compound which we are going to get over here. This one, at alpha position there is a hydroxy group, so we can say it is a alpha naphthol, or we can call it as a 1-naphthol. So this is a very simple and the easy method for the preparation of alpha naphthol. And the side, how do you confirm whether this reaction is completed or not? By complete evolution of ammonia, which is a side product formed during the synthesis of alpha naphthol. So this is the one method which we have seen over here. This is alpha here this is not the alpha, here remember this is not the alpha naphthylamine, or we can call it as 1-amino, or we can call it as a 1-amino naphthalene. So make the correction over here. The starting material which we are using alpha naphthol can be obtained by hydrolysis of corresponding amine. So the amine which we have taken in this case is alpha naphthylamine, or IUPAC name of this compound is a 1-amino naphthalene. This the group, functional group, which is known as a amino, just like as a chloro, fluoro, nitro, bromo, like that. This is a way of altering the name of that functional group. So remember here it is a 1-amino naphthalene. So that is the compound which we have. Now let us look at the preparation of naphthylamine. How do we prepare this naphthylamine? Starting from the naphthalene, that are the things which we are going to discuss over here. We are discussing generally the reactions of naphthalene, right? Reactions of naphthalene which we are discussing in this under the heading polynuclear and the heteronuclear aromatic compounds. So here fifth one is the preparation of naphthalene amine. Fifth point is the preparation of naphthylamine. Preparation of naphthylamine. Preparation of naphthylamine. Naphthylamines, you can call it naphthylamines. How do you prepare this one? So by taking as a different starting material, we can prepare the naphthylamine. So here alpha naphthylamine is industrially prepared by reduction of alpha nitronaphthalene, and it is also prepared by direct amination of alpha naphthals. So there are the two starting material we can take for the preparation of naphthylamines. First method, we can take the starting material, generally this one. Suppose we have this is one of the compound, as we know that NO2, right? And as we know that when NO2 is treated with, there are the two selective reducing reagent, Fe in presence of HCl or Sn in presence of HCl. This is a two very good reducing reagent. What they will do, they will reduce that nitro group NO2 into as a RNH2. This is one of the best method for the preparation of amines starting from the nitro compound. So here this you can consider this is a R just over here. If it is treated with Fe in presence of HCl, that reduction takes place, reducing reagent, this is a reduction, and what do you get? You can use this or Sn in presence of HCl. These are the two alternative reagent, industrial process used for the preparation of this alpha naphthalene. So we can get over here, this is one way of the preparation of this. If that nitro group at this position, we will get the corresponding naphthylamine. So that the things, just if it is this one, this is a compound which we have got over here. Suppose we have a starting compound, this one NO2, then this we are getting alpha naphthylamine, and when it is treated with the same reagent Sn in presence of HCl or Fe in presence of HCl, what do you get? You are going to get the product, this one. This is a product which you are going to get. Only the position of that amino group remains as it is, because reduction, this is a reaction center, so this is going to reduce into that one, and the product which we are going to get as a beta naphthylamine, that is a product which we are going to get in this case. So this is one of the way of preparation of naphthylamine starting from the nitro as an starting material. Now another way of preparation of the naphthylamine will be, just you can take as a starting material different one. Suppose if you take as a starting material is a beta naphthol, as we know that it is readily available. So one can get essentially this is a beta naphthol or alpha naphthol, we can call it. Here is a alpha naphthol OH. This is a alpha naphthol which is a starting material. When this alpha naphthol will be treated with the ammonia in presence of zinc chloride, and temperature is near about 250 degrees centigrade at high temperature, the resulting compound obtained will be as a alpha naphthalene. That are the industrial process for the synthesis of beta naphthalene. Here you can use as a ammonia in presence of ZnCl2 zinc chloride, and the temperature kept near about as a 250 degrees centigrade. The resulting compound obtained will be this one. The compound which we are going to get over here in this particular case is this one, NH2, and this, the resulting compound or the product form is nothing but as alpha naphthalene. So this is alpha naphthylamine. So which is the product or IUPAC name. In a previous example we already know that the IUPAC name of this compound, which is a 1-amino naphthalene. So that is the way of giving that IUPAC name. Now next one is a Bachelor reaction. What is that Bachelor reaction? Bachelor reaction is also as a one of the famous reaction, and from that we can get the that naphthylamine, preparation of that naphthylamine, that is we are discussing. And second A we have seen here. In case of the B is a Bachelor reaction is known as a Bachelor reaction. B is a Bachelor reaction. And how the Bachelor reaction, what he had prepared and why the name is given to this synthesis. Alpha and beta naphthylamine are obtained from corresponding naphthol by heating with bisulfite and ammonia at high pressure, very high pressure. So and that's why we will get this reaction. It's a Bachelor reaction. What he did, alpha and beta naphthylamine are obtained from corresponding naphthol by heating with bisulfite NaHSO4 and ammonia at high pressure. So what he did, he had taken the starting material is this one. This is a starting material which is a alpha naphthol, that will be treated with ammonia in presence of bisulfites. Bisulfites, as we know that bisulfite is nothing but as NaHSO4, sodium bisulfite, and heated at very high pressure, is kept industrial procedure, and therefore he got the end product or the resulting product, this one. The name of this product, everybody knows that the OH get replaced by the NH2, so that the product is formed. This is as we know that this is alpha naphthol, which is a starting material he has taken for his synthesis, and he had prepared the compound which is a alpha naphthylamine, that is a compound he prepared starting from the alpha naphthol. And the second starting material, he has prepared the corresponding alpha and the beta naphthalene starting from the corresponding, in the first alpha naphthol, starting from alpha naphthol, he got alpha naphthylamine. When he started with the beta naphthol, he got as a beta naphthylamine. That's a very simple principle involved here. This is a beta naphthol, as we know that beta naphthol, when it is treated with the same reagent, that is ammonia NH3 in presence of sodium bisulfite NaHSO4, heat it at high pressure, the resulting compound obtained will be this one. You can see, you can observe this structure carefully. Here at beta position, that amino groups attached or present, and that compound is nothing but as a beta naphthylamine. Beta naphthylamine. So that is a structure which we got over here, or that is the compound which he has prepared in the laboratory, starting from this one. Now let us look at as a next reaction. Next reactions are 6. One is a Friedel-Crafts acylation reaction. Friedel-Crafts acylation reaction that we are talking about. Friedel-Crafts acylation reaction, because we are discussing the reaction of naphthalene. So far, different methods we have discussed the reaction of naphthalenes, and now here the Friedel-Crafts acylation reaction that we are talking about. And as we know that Friedel-Crafts reaction, generally what do you mean by the Friedel-Crafts reaction? There are two types of the Friedel-Crafts reaction. One is called as a Friedel-Crafts alkylation reaction, and another one is called as a Friedel-Crafts acylation reaction. In Friedel-Crafts alkylation reaction, or this Friedel-Crafts reaction is nothing but the alkyl group or the acyl group introduce an aromatic compound in presence of Lewis acid. Generally aromatic compound, simplest aromatic compound we are discussing about that naphthalene. When R group is introducing in the benzene, means as we know that aromatic compound readily undergoes electrophilic substitution reaction. So when alkyl halide treated with the simplest benzene without Lewis acid, it will take long time, maybe as a 6 month or 4 month, to introduce that alkyl group, or there is a possibility reaction may not occur. But if you use a catalyst, Lewis acid generally, then the reaction, rate of reaction is a speed up or the increases, and the introduction of alkyl group in aromatic compound takes place. Means there is a formation of new carbon-carbon bond, and therefore synthetically this Friedel-Crafts alkylation reaction is playing as a big role in the synthetic organic chemistry. And therefore, what is the role played by the Lewis acid in this particular case? Due to the presence of Lewis acid, it generates the electrophile, and once it generates the electrophile, the nucleophile, which is a source of electron present in the aromatic compound, easily attack on that electrophile and the reaction takes place. Means in an aromatic compound, one of the hydrogen atom get replaced by the alkyl group in presence of Lewis acid. That reaction is known as a Friedel-Crafts alkylation reaction. And another one is a Friedel-Crafts acylation reaction. Means what? In an electrophilic substitution reaction, one of the hydrogen atom get replaced by the acyl group RC double bond O in presence of Lewis acid. That reaction is known as a Friedel-Crafts acylation reaction. These are the two main reactions which are occur in the aromatic compound. They are readily undergoes as a electrophilic substitution reaction, mainly for aromatic compound, and that is known as a Friedel-Crafts reaction. Two type of the reactions are generally taking place, and I think with this let us stop today here. Remaining reactions, actual Friedel-Crafts acylation reaction in this particular naphthalene, and as I already told you that naphthalene is a more reactive than aromatic compound, and therefore similar to as a benzene require Lewis acid to speed up the reaction or to take the reaction to occur the reaction. But in case of the naphthalene, naphthalene itself is a more reactive. So in a reaction, there is no need of Lewis acid catalyst over here, because the naphthalene itself is a more reactive, and due to this reason, without Lewis catalyst, the electrophilic substitution reaction occur in the naphthalene, and that Friedel-Crafts acylation reaction, that is a known reaction we are generally discussing over here. So I think the detail of that Friedel-Crafts acylation reaction we will see in our next lecture. Till then, have a nice day. Thank you.